Hey Muffins, welcome back to school. I just thought I would take a minute and show you your revised calendar that I created due to this great coronavirus. I have already put it on Google Classroom so you can see it and keep up with it. There are actually 2 pages to it because it just got a little long and I just wanted y'all to have it to see it. But there you go, it's there. And today is Wednesday, March the 25th, and we're going to be working on lesson 13.3. So what I'm going to suggest that you do right now is get out the notes that say section 13.3. We're going to be looking at evaluating a trig function. And I'm also going to maybe recommend that you take out just a plain sheet of notebook paper because that is actually what I'm going to do first, okay? So before we left for spring break, I asked you to find the sine of 30 degrees without a calculator. And I told you that if you didn't have a calculator, what you needed to do was go draw a right triangle and let one of your angles be the given angle. Of course, my little white pen is off a little bit. So when I say the sine of 30 degrees, what you wound up creating was a 30, 60, 90 degree triangle, which you know is 1, 2, the square root of 3. And then, because of SOHCAHTOA, we said the sine would be equal to the opposite over the hypotenuse, so opposite of a hypotenuse. So the sine of 30 degrees is 1/2. So that's how we found the trig ratio without a calculator. So today, what I'm going to ask you to do is find the sine of 150 degrees. But there's going to be a huge problem that you run into. And that problem is, if you were to do what we just did and draw a right triangle, there's absolutely no way to make one of your angles 150 degrees. I mean, it's just not going to happen. So we're going to need a little help. We're going to need something really easy to do. And I'm going to show you that right here. And I'm kind of giving you an overview of what's happening. You will draw a 150 degree angle, which is somewhere over here in quadrant 2. We kind of talked about that right before spring break ended. And what you're going to need is a reference angle. And a reference angle is always found between the x-axis, it's always the x-axis, and the terminal side of your angle, which is basically where it ends. And the little symbol that you use for a reference angle is called theta prime. If from here to here is your big angle theta, in this particular case 150 degrees, then the little reference angle that we need to help ourselves is this guy right here. And again, I'm going to say this again, it's always next to the x-axis. And if you will remember that, I think you'll be just fine. So the question that I'm going to need y'all to kind of think with me, if from here to here is 180 degrees, and from here to here is 150 degrees, does it make sense to you that theta prime will be 180 degrees minus 150 degrees, which would be 30 degrees? So this angle right here is a 30 degree angle. And I think that makes sense to you. If from here to here is 150 and from here to here is 180, you're kind of 30 degrees shy of being that full straight line. So this guy right here is called a reference angle. And we can find these anywhere we need to. And I'll do another example here in a minute when we're in another quadrant. The next thing you are going to do is create a cute little reference triangle. And it's called drop a perpendicular. And it is always dropped to the x-axis. The reference angle is always next to the x-axis. You always drop your perpendicular to your x-axis. And what you just created was a cute little triangle that just so happens to be a 30, 60, 90 degree triangle. And once again, you already know the lengths of a 30, 60, 90. It's 1, 2 in the square root of 3. Okay? Do you see how that worked? Now, this is correct. We are accurate. And in all reality, there is technically no such thing as a negative length to the side of a triangle. However, if we're on a coordinate plane, when you go to the left of 0 on the x-axis, these numbers are negative. If you were to go up, although my going up is over here, this number right here is positive, okay? So when I now want to do the sine of 150, I'm going to use this reference triangle and this reference angle to help me understand what the sine of 150 degrees is. I'm going to do sine, which is opposite over hypotenuse. So the sine of 150 would be 1 over 2. So this is kind of what our objective is today. We're going to be looking at how to find reference angles, how to drop a perpendicular to make a reference triangle so that we can evaluate trig functions and come up with the trig ratios.